Hey, what's up YouTube? So in this video I'm going to be showing you my recently built phone charger here. This is a portable and rechargeable cell phone charger which uses two PC lithium-ion batteries as the power source. And here I have the power board for charging and recharging a phone. And here is a USB cable that I'll be using for testing. These batteries have high performance capabilities and have a max capacity more or less of 1,500 milliamps per hour. So here I have the battery pack in idle mode, and I have probed the positive and negative connections here. Voltage readout of 4.12 volts there. And here I have the negative probe of the battery pack connected to the positive input chip of the battery management board here. Here I have the negative probe of the battery pack connected to the MOSFET chip. And here's the other MOSFET chip here. USB-A, micro USB. This board is comprised of the input side of the board as well as the output side of the board. The positive battery pack connection is connected to the B plus side here, while the negative side of the battery pack is connected to B minus over here. The input side of the board here works by inputting your micro USB adapter here, which then plugs into your 5 volt USB-A connector inside your laptop for recharging. And here I've installed a red LED for indication of recharging. And the bulk of the recharging capability comes from the battery management chip right here. And that's backed up by quite a few surface mount components such as capacitors and resistors. As for the output side of the board, we have this big inductor right here, and we also have two dual N-channel MOSFETs that do the bulk of the power switching as well as protection from over-discharging or overcharging of the cells here. And here I have the device recharging via the 5 volt USB-A output connector. Alright, so about an hour later we have successfully recharged these batteries here, and we see the green LED emission which indicates a completion of charge just using the laptop USB connector here. And here we can see a potential voltage readout of 4.2 volts there, which is indicative of a fully charged battery. Alright, so here I've connected my phone to the charger here via this USB-A to micro USB adapter. And we have here an indication of charge via this blue LED emission. And here we see the indication of charge on my phone via this red LED here. And if we check my phone here, we can see we are currently charging at 73%. And it is currently 5:13 p.m. Alright, so here we are currently sitting at 88% of charge. It is just after 5:30, 5 after. And here we see a fairly steep incline back to our nominal 100% range. So based off of this information regarding my battery on my phone here, we should see a fully charged battery in about 15 minutes or so. 95% and a much steeper incline here going up, almost there. And here we are at 100% charging. We'll know that the completion is done once we see a green LED indication on my phone, but technically we are at 100% now. And here we see our completion of charge LED indicator. So as you can see here, the charge rate has sloped off at the peak there, and will now start discharging down this way. And here you can clearly see that curve now occurring in the discharge rate here. Sitting at 96%. And as predicted, so within 96% of discharge rate, we see the discharge curve leveling off after it drops right about here. So that should continue for the next little while. So overall, this is a good phone charger. It is portable and rechargeable. It was cost effective in terms of putting it all together. The holder came to about 99 cents, with the board being about $12, and these batteries came for free out of a cordless drill set. So this is a reliable and also efficient charger, especially in terms of its charging rate and rechargeability. and you can get long life duty cycles out of this unit here. So I'm actually quite happy about this.